What if your password was something that you couldn't forget, you couldn't lose, and couldn't have stolen? Well, that's the promise of behavioural biometrics. Behavioural biometrics uses technologies to analyse unique patterns in how we naturally behave and interact with our devices. This market is expected to reach about $13 billion worth by 2033, and it's growing at about 24% a year. A lot of it sounds like science fiction, but it's already being widely used by banks and financial institutions, plus other secure areas. Behavioural biometrics analyzes how people naturally interact with devices and systems to verify their identity. So unlike traditional biometrics that measure physical traits, this technology focuses on patterns in human behaviour. It works in the background and creates a unique behavioural profile based on any number of metrics, which can include digital interactions, how we use devices, cognitive patterns, our decision-making styles, and physical movements such as keystroke cadence or the way we walk, which is gait analysis. So for example, banks might analyse form filling behaviour on their website to see how quickly someone enters data, their patterns of navigation between fields, whether they copy paste or manually enter data, and how they go about correcting errors. It's nearly impossible to replicate someone's natural behaviour patterns, and the technologies used for behavioural biometrics adapt to gradual changes in user behaviour over time. It's a massive field, and there are more sort of subfields being investigated every day, but here are some we can look at that are already in use. So we have body movement or kinesthetics. So this can include posture analysis to see the weight distribution of how someone walks or sits, also the way they hold their device, what angle they hold it at, the arm swing of their movement whilst walking and so on. There are voice patterns which are quite common in a lot of films. So voice analysis looks at sound variations during speech, vocal patterns that are unique to individuals, and natural speech rhythms. And then there's also device-based input, which can include keystroke dynamics, mouse movement characteristics, touchscreen interaction patterns, and cursor velocity and acceleration. One of the big differences, at least at the moment, between humans and bots is humans tend to use variable speeds and natural pauses between their actions. Bots, on the other hand, use linear movements and consistent speeds. And there are natural inconsistencies in human behaviour that, certainly until recently, are not replicated by bots, although with the growth of AI this is likely to change, of course. So yes, there are lots of fields of behavioural biometrics. There's a few more on the screen now rather. Everything from eye movement to time of day usage, location-based patterns, the gait recognition that we mentioned earlier. Each one of those has subsections and sub-areas. So if we look at just keyboard dynamics, for example, of how someone uses the keyboard, you've got speed and rhythm, you've got error correction, you have keystroke pressure, copy-paste behavior, and there's more too. It really is a field where areas of research are increasing daily. So interesting, certainly. How does it actually work? Well, what we need, first of all, is we need to collect behavioral data from the users. So we need to create a user profile from that data to establish a baseline of what this individual's behavioural characteristics are. There'll be a processing stage where this raw data is collected. We want to eliminate noise, we want to extract features and patterns. And it's important at this stage that the right metrics are used for the appropriate purpose. There's two phases for the modelling stage. We use the enrolment stage where the system creates an initial behavioural profile. And then there's the verification stage where the continuous monitoring is put against this stored profile. This obviously can leverage AI and machine learning. The evaluation process calculates a confidence ratio and compares the behaviour against the stored profile, and then makes authentication decisions based on that output. So behavioural biometrics offer unique advantages over traditional authentication methods that make it particularly valuable for modern security needs. So generally no special hardware is required. Most solutions use existing devices such as keyboards and mice and touchscreens, and this reduces the implementation and maintenance costs significantly. Behavioural patterns are nearly impossible to replicate, and unlike passwords or tokens, behaviours cannot be stolen or shared. These systems can continuously monitor for suspicious changes in behaviour, but can also adapt to gradual changes in behaviour over time. Users don't need to perform specific actions, and authentication can happen naturally during normal device usage, so there's no additional steps or interruptions to workflow. There are, of course, some challenges. Different devices can produce varying results for the same user. Stress levels can impact behavioural patterns. Physical conditions such as illness or injury can also affect these patterns, as can the time of day. There are some technical limitations as well, where spoofing attacks can take place by using recorded behaviours. Replay attacks can use previously captured data, or coercive impersonation or forced authentication can bypass some of these methods. There is an arms race, as you can imagine, with behavioural biometrics, where for each one of these weaknesses there's a new solution coming through, and then each one of those new solutions will then be undermined in some way. Also, we are talking about collecting a lot of data, very personal data from people, so behavioural patterns may reveal health conditions. Movement analysis can indicate emotional states, and continuous monitoring in general raises ethical questions, particularly when it comes to secondary use of this collected data. So behavioural biometrics is already being successfully deployed across multiple sectors. So banks are using behavioural patterns to detect account takeovers in real time, to identify social engineering scams, monitor suspicious transaction patterns, and protect mobile banking applications. In the workplace, there is continual employee monitoring in some businesses, and this takes place without disrupting the employee's workday. This is to provide protection against insider threats and secure remote access verification, and also general workstation control. Hospitals are using this technology to safeguard health record access, medical device authentication, remote patient verification, and also prescription security. And plus we see mobile authentication happening daily with app access controls, mobile payment verification, device handling patterns, and touchscreen interaction analysis. A big part of successful behavioural biometrics usage is getting the performance metrics just right. So we have two main metrics, which is the false acceptance rate, which is the percentage of imposters that are incorrectly authenticated, and then we have the false rejection rate, which is the percentage of legitimate users that are incorrectly rejected. As you can imagine, the more sensitive and demanding you tune your application to be, the higher the amount of rejections, both false acceptances and false rejections. The equal error rate, the EER, or sometimes known as the crossover rate, the CER, is where the false acceptance rate and the false rejection rate meet. And this is the sort of industry standard for comparing different systems. A lower EER indicates better system performance. And there are many variables that impact the performance of this system. Environmental conditions, user stress levels, physical conditions, technology being used, and so on. This is where a lot of time and money is spent by the behavioural biometric companies to get their systems to perform as accurately as possible and as reliably as possible, but without making the user's experience particularly difficult with false rejections or requiring them to re-authenticate multiple times. If we look at that another way, on this graph, you can imagine where if you have high false acceptance and high false rejection, that's a massive security risk. If you have high false acceptance and low false rejection, it's overly permissive. Balanced performance is where you tend to have higher false rejections and lower false acceptance rates. So you can imagine it will err on the side of saying no rather than yes, which is the safer side to err on. Ideally, you'll have a low false acceptance rate and low false rejection rate at the same time. Easier said than done, of course. Future trends, it's going to be a massive industry. Absolutely, it already is, really, multi-billion dollars. AI integration is, as with everything, the hot topic at the moment. Looking at how AI will enhance the capabilities for predictive analysis of user behaviour, preemptive resource allocation, real-time threat detection, all that exciting stuff. Then we have Internet of Things integration. There are about 26 billion internet-connected devices in the world at the moment. What's that going to be used for? How are they going to mesh together? And multimodal systems, where you'll take multiple types of behavioural biometric and link them together. So you might have facial recognition plus voice recognition, maybe gait recognition. You can imagine walking over a floor in a secure office, and by a combination of cameras and sensors in the floor, it will monitor your gait pattern and double check that you are who you say you are. General best practices. Behavioural biometrics is best used as a part of a multi-layered approach and combined with traditional authentication methods. It has its strengths, like continuous background verification, and this creates a defense in depth strategy. But we've already mentioned some of the potential weaknesses of behavioural biometrics, and it is a whole other attack plane for people to go after with the existing weaknesses in behavioural biometric systems. BioCatch is one of the largest behavioural biometric suppliers at the moment, and they have some interesting case studies which you might want to look into if this area interests you. They cite a top 5 US bank that generated 12x return on investment by accepting more credit card applications, decreasing operational costs and reducing fraud and losses by implementing behavioural biometric monitoring in their application process. And with a 99.93% approval rate for genuine applications. Generation after next, behavioural biometrics. Hard to say, but we can guess there'll be some type of brain-computer interface where cognitive functions, brainwaves, will be directly linked to the devices that we're using. So thought-based access control, perhaps, and emotional state monitoring to see if someone is under duress or not. Environmental mesh, so we'll have smart cities linked with the Internet of Things, linked with our devices. Quantum computing is still in its very early stages, but when we can harness that power, then the computing power of that will enable us to do behavioural biometrics on a much bigger scale, even faster real-time processing. And biodigital fusion, which is a really interesting field where sensors are put into everyday objects. So you could even having a sensor in your pen, for example. And behavioural patterns are merged with these physiological markers. So not only the way you hold the pen and write with it, but the pen might also sense your heart rate and blood pressure and your temperature to see, for example, if you're under duress, if you're doing something because you're being blackmailed, for example. Your biosignatures will be higher than a normal day at the office. Plus there's health monitoring benefits as well, and adaptive environmental responses. So behavioural biometrics is a massive field, not one we can cover quickly. I think I'll dive into a few of these subtopics in more depth soon. So if that sounds interesting, I'll see you in the next video. Make sure to hit subscribe so you know when that comes up. And if you have any questions, either contact me directly or leave them in the field below. Bye for now.